Hello, welcome everybody. Welcome to my talk on upgrading your existing project to the Universal Render Pipeline. My name is Yilmaz Kiymaz. I am a Unity developer at InnoGames in Hamburg, Germany. And I'd like to talk to you a bit about what it takes to do this transition. So, better enter play mode. So, when you do a literature search on the topic of Universal Render Pipeline, you find a lot of great information on what you need to do to start a new project with Universal Render Pipeline, but not so much what you need to do when you want to upgrade an existing project to it. And that's really the kind of knowledge gap that I want to fill with this talk. And if, like me, you're working on a project that started out using the built-in render pipeline and is now at a good point to upgrade to the Universal Render Pipeline, then you are at the right time in the right place, so congratulations. Because I would like to show you the ultimate way of upgrading to Universal Render Pipeline with guaranteed success or your money for Unite back. All right, so, there we are. There's a lot of information out there about the intro, so we'll skip the intro. There were some talks at this Unite about intro to Universal RP, and there were talks at previous Unites, such as Unite LA 2018, and there's also a tutorial series on Unite Learn about introduction to LWRP, which is what Universal RP used to be called. Before we get into the meat of the presentation, I quickly want to touch on the acronyms that I'll be using to remove any potential confusion. So, Universal RP is Universal Render Pipeline, which supersedes LWRP, which is Lightweight Render Pipeline. And Universal RP is an SRP, which means a scriptable render pipeline, which is part of Unity's new system to allow developers to hook into Unity's rendering and customize it to their heart's content. Let's quickly go over what we will talk about. We'll first touch on why would you want to upgrade an existing project to Universal RP in the first place, and hopefully once you're satisfied to a good level, we'll get on to how do we actually do the upgrade. We're going to get to know Universal RP's shader library a bit, and we're going to talk about upgrading your shaders and upgrading effects. And we're going to also touch on some known issues with Universal RP at the moment and potential workarounds. And then we're going to wrap up the talk, and hopefully if there's enough time, I'd like to ask the audience if any of you have gone through at least part of this process of upgrading to share some of your experiences with it, because there might be something I haven't stumbled upon that you have, and then everyone here can benefit from that as well. And then we'll do the usual Q&A. By the way, this Unity project that the slides are in and all the information and the demo scene is in will be available, actually is available right now online, but the URL will be revealed at the end of the talk. So why upgrade? The first thing that obviously comes to mind is performance. We all want more performance. And I found with my time with this package that Unity has kind of collected all the learnings that they've had over the years and this time around made a more performant and more flexible system. And it's actually possible to notice a performance improvement as soon as you do the upgrade properly without resorting to any kind of additional trickery. And cases of performance degradation are treated as bugs by the Universal Render Pipeline team. So if you upgrade your project and then you find specific instances where it's performing worse than built-in render pipeline, you can report these as bugs and they will get looked at. Also, the SRP batcher that we are able to use using Universal Render Pipeline is a much more improved and easier to use batching system than the dynamic and static batching system we all have a love and hate relationship with. Second point is usability. Using an SRP allows us to use shader graph to author our shaders visually in a node-based graph, which also would allow someone who's not a shader developer or isn't knowledgeable about writing shader code to be able to author effects. It's also very easy to assign different rendering settings, completely different rendering settings per camera through the inspector, and advanced rendering features such as custom passes that draw specific objects with specific effects is also configurable via the inspector. Third point is customizability. There are several levels of customizability when you're using an SRP. You can write custom renderer features, you can write custom renderers, you can write custom SRPs. And you can also take Universal RP as a baseline and fork it from whichever version that you want, make your own modifications to it, put it in your project as a local package, and ship it. Final point is future-proofing. So built-in render pipeline is not being actively really improved anymore, even though there might be bug fixes and such. So really, to be in a good place for the future, you want to be on Universal RP so that you get additional features and improvements down the line. Okay, so now we get on to how do we do the upgrade. The first two steps of the upgrade process is the same as you would in a new project. You go to the window menu, then go to Package Manager, find Universal RP, and here there'll be an install button. Right now it's not because it's already in this project and I'm in play mode. And then the second step is to create a render pipeline asset, which I already have over here. You just right-click, create, rendering, universal render pipeline asset, create the asset. It also creates this renderer next to it that's already linked automatically. And then what you need to do is go to Project Settings, Graphics, and drag and drop it in there. And now we're actually rendering with universal render pipeline. What we're going to do, because we're upgrading an existing project to it, is we're going to see, okay, how can we replicate our effects and shaders in this new render pipeline? And for that, we're going to look at the simple lit shader that comes with Universal RP and get to know the shader library of it a little bit, because it's quite different compared to the shader library or the library of code for writing shaders in built-in RP. And then we're going to hopefully upgrade our shaders, upgrade our effects. So I'm going to go ahead and open this demo scene that I have here, and everything is pink. That is because we are right now using Universal RP, and none of our shaders are compatible with Universal RP. I have a little shortcut here in the Tools menu to switch render pipelines easily, and it has a shortcut, Alt-Shift-R. So if I click that, I can switch between, or with the shortcut, Universal and built-in quite quickly. All this does is basically assigns null, or our render pipeline asset object, into this field over here. I hope you can see that. Yep. So obviously, Universal RP is not working for our demo scene, but let's take a look at what's in the scene when it is working in built-in RP. We have a simple lit shader for the ground tiles, also for these props. We have another shader for the vertex transformation-based swaying that you see in this vegetation. We have another shader for the coastline wave effect, and another shader for the water. So that's 4 shaders. And by the way, this is a battlefield scene from the tutorial of one of our games, Warlords of Eternum, that they so kindly let me actually put into this project that's already on GitHub. So let's take a look at our shaders. They're over here. Custom lit, custom tree sway vertex used for the vegetation, custom water, custom wave. They're all relatively simple. If I open them up in Writer, let's actually close everything first, and enter presentation mode. How readable is that? Looks good. Okay, so this is the custom wave shader, has a main texture and a wave speed, is a transparent shader that does blending, and very simple vertex and fragment programs. Same really with our other shaders, so custom lit has, again, a main texture, a planar UVs toggle, which I will get to in a second, and again, simple fragment and vertex programs. We have the custom tree sway vertex shader, which has a few more properties, like time offset, band speed, brightness. And you can see in the vertex shader, we're actually moving around the vertices a bit. And finally, we have the water shader, which has its own properties. And you can see the vertex shader is a bit longer, and the fragment shader as well. So we're going to try to convert these to be Universal RP compatible. But before going ahead and messing with code to do this, maybe we can actually do it with shader graph, right? Because we can use it now. Let's switch over to Universal and select any one of our objects. This one has the battlefield Greenland water material. I want actually a lit. Yeah, if I switch back, yeah, this one should do. This one uses a custom lit shader. First, actually, let's try the simple lit shader to see what that looks like, and then we're going to try shader graph. So if I go here and under Universal Render Pipeline, select the simple lit shader, you see I'm actually getting something besides the pink color of the error shader. So there is actually some lighting you can see along the coastlines, and the color is just gray. And the reason we lost the texture is because the name of the property that the simple lit shader uses for the texture, main texture, is not underscore main text, as it kind of was the convention before, but underscore base map. But that's no problem. We can just kind of reassign the texture, and then we get something rendering with texturing on Universal RP. But you can see there's something off with the texturing. It's not quite tiling properly between the hexes. And the reason for that is this planar UVs toggle that I talked about earlier. So if I undo my changes and switch back, and with this still selected, come here and turn off planar UVs, you see I get the same effect. And the reason is, instead of using the UVs that come with the model, the shader is actually calculating texture coordinates based on the object space position of the vertices, the x and z axes, respectively. So we need to replicate this somehow. And unfortunately, the simple lit shader doesn't really give us a chance to do this. It doesn't have the functionality to do this. So any of the options here, there's nothing that talks about kind of world space UVing as this technique is known. So we have to do something else. And we might resort to writing our own shader and shader graph. So let's go ahead and do that. I will go ahead and create a new shader. And here are the graphs. And the PBR graph is really the only one we can choose because that's the only lit one, even though we don't really want PBR. But that's OK. We can turn off many things that we don't want in there. And I'm going to name this custom lit shader graph. Open this up. And shader graph, at least in this version of Unity, I'm on 2019.3 It's a little buggy. Stuff starts disappearing. But if I just kind of refresh it, it comes back to life. So here's our master node. If we don't do anything and just assign this shader to be used on this material in shader graphs, custom lit shader graph, we get an even worse result than with the simple lit because we don't even get any lighting. It's just white. So we got to do something here. Go back to the shader graph, and we want to sample a texture and put the result of that sample into the albedo. So I will create a new node for sampling a texture, sample texture 2D, and I will actually need to define the texture as a property here. Call it, actually this can stay as a texture 2D, but I want to name it underscore main text so it's compatible with our existing shaders. Drag and drop it in here, feed that into the sampler, and we're right now using the UVs of the model as before, and the resultant color gets fed into the albedo. We save this and go back, and I assign the texture, and now we have the texture appearing through our shader graph shader. Now you see there's a bit of a highlight here. It's the specular, and I don't really want that, so I can set the smoothness to 0, save again, and the specular goes away. And now I'm going to work on doing this world space UV. And that's actually relatively simple in shader graph as well. So instead of using the UVs that come with the model, we want to calculate our own. So I will take the position node, which gives me the positions of the vertices in object space, and then I could actually try to directly feed it into UV, see what happens. Save and go back. And now we get this stretchy mess. And that's because the position has x, y, z components, and the UV only uses the first two. It uses x, y. But we actually need to use x, z. So we need to kind of do a little swizzling. So let's come back here. Create node for splitting this. You see how stuff is disappearing. We just have to do a little refresh. Feed it in, and then create a combine node. And take the r, which is the equivalent of x, and the z, which is the equivalent of b, in here, and then take this two-value vector and feed it into the UV. Let's save it, go back, and now we have properly tiling texture. But it still doesn't quite look right as it used to, and that's because of the scaling, because if we open the custom lit shader, you see there's a hard-coded scaling of 0.3, which isn't really where you would want to put it. You would want to make it a property, but in any case. These shaders aren't the most well-written shaders. So let's just replicate this multiplication of 0.3 before we pass it into the sample texture node. Here we go. Get a little multiplication node in here. Refresh. And feed it in. Multiply both values by 0.3, 0.3. It's annoying, right? And then feed it out here to the UV. Save, come back, and that looks much better. Much more like what we had before. In fact, we can switch back. So I use the shortcut to switch render pipelines, goes pink. I need to change the shader on here, back to lit, and close enough. Now, the problem with this approach is now I have my old shader, which is only compatible with built-in RP, and my new shader graph shader, which is only compatible with universal RP. And if I use my shortcut to switch rendering pipelines, if it decides to work, yeah, there we go. We first get this pink color, right, of the error shader because it's not compatible. And then we have to switch the shader. We could do this. We could also add this functionality to the shortcut to perhaps have a mapping of one shader to another to go over all the materials in the scene and swap the shaders, but it's really quite cumbersome. And we would really like a solution that works without having to do all this extra stuff. And there is a way. But that requires us to write our own shaders in code, just like the previous shaders. And we're going to get into that. So, switch back to built-in. And actually, our material is set back to the custom lit. And open up our custom lit shader. We're here. The trick is to have one subshader compatible with built-in render pipeline and have another subshader compatible with universal render pipeline. So I'm going to go ahead and duplicate this and put it up top. And then, in the subshader tags, I'm going to add a tag, render pipeline equals universal pipeline. Okay. There's one more change we need to make. We need to, in the main path, change the light mode from forward base, which is some keyword that's applicable to the built-in RP, to universal forward. And if you come back and switch back and forth between the built-in and universal, you see that our lit shader is actually now compatible with both render pipelines, and it's looking exactly the same, which is great. So we just need to do the same for the rest of our shaders, right? Let's go to the vertex tree sway shader. Take the subshader. A little bit of manual work, nothing wrong with that. Let's just copy the stuff, though, from the other shader that we wrote already. Take that, take the tag, go back, switch pipelines, and you see the vegetation's also correctly working in the new render pipeline. 2 shaders left, water, subshader, copied the render pipeline tag for the subshader, and copy the light mode tag for the main pass. Okay, so that was the water. Now the water is also working whenever we switch. And finally the wave. Subshader is copied. Render pipeline tag copied. And light mode tag copied. Give me a second here. Sometimes the shortcut just decides not to work, or Unity decides to crash. But that happens. We just have to relaunch it. Funny thing is, Unity crashes, and then Unity bug reporter tries to pop up, and the bug reporter crashes. So it can't really do anything. All right, back to our battlefield scene. And if we switch between the two render pipelines, like it's hard to believe that we are switching between them because it looks exactly the same. So great, our shaders are working. It's this simple, right? No. There's a little problem. If we switch to universal and click on our shaders, we see this little message here. Our shaders are not compatible with the SRP batcher. And it finds built-in properties that are not in some specific C buffer that it's looking for, and that causes a problem. And there really isn't anything we can do about this unless we really convert our shaders to use the shader library of the universal RP. And that's what we're going to have to do. Because, I mean, you could, get by fine like this, but if you really want the good performance of universal RP, you want things to be SRP compatible, SRP batcher compatible. And if we look at the frame debugger, we can also see this right now, that these guys are being not really batched. Yeah, that's bad. Okay. So what does that take? We're going to have to take a look at the simple lit shader, because that's the simplest lit shader, as in the name, that comes with the universal RP, and kind of take all the bits from it that we need and throw away all the bits that we don't. And I think we're just going to do this for one shader, because the time it takes probably won't be enough for all 4 of them. So let's take a look at the simple lit shader. And actually first, let's take a look at the organization of the package itself. So we have universal RP here, and the shader library is here. There are several different files like core, lighting, particles, shader types, etc. And the shaders themselves are in here. And you can see the simple lit shader over there. There are some other files called simple lit forward pass, simple lit input. We'll see how they play a role once we open the shader. So this is our shader. It's quite long, and it has multiple passes. So a bunch of properties, most of which we don't need for our very simple demo scene. So like specular, bump, emission maps, and so on and so forth. And here's the subshader, and here's the first pass, which is the forward lit pass, and has the same tag that we used, light mode equals universal forward. and bunch of progma statements, bunch of multi-compiles, and the vertex and fragment programs to be used are declared here, but they're not here to be found because they're coming in from the include files. So simple forward pass HLSL file contains the vertex and fragment programs. So this is where they come from. And there's also a lot of stuff in here that we don't need. But our best bet really is to just copy it in and remove the parts that we do not need. And the other include file was the simple input include file. And in here, we have the C buffer and a sample specular smoothness function that we don't need, and a declaration of a spec gloss map that we also don't need. But as you can see, this include file further includes other files in it. So we really have to know from which level of abstraction that we have to pull these functions from, and what we want to rely on and what we don't want to rely on in the shader library, because you don't want additional cruft to get into your very simple shaders that might need to run very fast on mobile. So switching back to custom lit, we're going to replace our universal RP compatible subshader, most of its contents, with the simple lit. So let's take a look. I want to make sure I'm switching between the right shaders here. Yeah, simple lit is here. Okay. Instead of using CG, we start using HLSL, which isn't that much different. But there are just tiny few differences, and we'll get to those. So the name and the tag we have, and the name doesn't really matter. And the blend, zwrite, and call parameters, we don't need to change those from the default. So we begin with HLSL program instead of CG program, and end with and HLSL. So far, so good. Obviously, we can no longer use the include files that we use from the built-in render pipeline. So I'm going to go ahead and comment that out, even though that's going to, right now, if I were to go back, lead to compilation errors. We're going to replace it soon enough. And then in here, I'm going to take this bit, which is some stuff, as it says, required to compile GLES2 with standard SRP library. Go ahead and paste that in there. I don't need all this material options, such as emission, normal map, etc. I don't need switches for main light shadows and so on. None of these. For now, let's not care about instancing. And then we just have to actually go ahead and take our vertex and fragment programs. So paste those in, and then go to simple lit forward pass, and copy those guys in. Now this is going to look huge, but we're going to get rid of a lot of it. So take this guy, actually even the include for the lighting, because we need that. And back to custom lit. Replace the vertex and fragment programs with this monstrosity. Okay, beginning with the attribute struct, we're going to get rid of what we don't need. We don't need tangents because we're not doing normal mapping. We don't need light map UEs because we're not using light maps, and we're not caring about instancing. So those are gone. This part's going to be a little fast, but if you have questions about it, then you can catch me at the QA session or afterwards, and I can try to explain in a bit more in depth. We don't need normal maps, so that stuff is gone. The normal we need for lighting, but we don't need view direction because we don't have view direction specific effects like Fresnel or anything like that. We don't care about fog. We don't have shadows right now. And the instance ID and the stereo output, which is for VR, AR stuff, we don't need. And I said we don't need light map. We do not, but this is like a macro to declare a light map or an SH, and SH is spherical harmonics, and it's necessary for ambient. I'm going to leave that as is for now. So there's this initialize input data function, where did that come from? So it's actually being used in the fragment shader, fragment program, to calculate some things that are going to be needed for the lighting. So in there, I'm going to try to get rid of some stuff that we definitely don't need. Normal maps, not needed. View direction, not needed. If you look at these two lines, it's just assigning to the same value twice. So might as well just put this guy in here. Whoops, that's better. Don't need view direction. Don't need shadow coordinates. Don't need fog. Don't need vertex lighting. Baked GI, we still need because that is used for the ambient, like I said. So this is where we got. And then we're in the vertex shader. Instance IDs are gone. Whoops. Cancel. Stereo output is gone. Vertex and normal inputs I'm going to leave for now. View direction gone. Vertex light fog factor gone. Normal map stuff is gone. View direction is gone. Light map UV is gone. SH stays. Fog factor and shadow coordinates are gone. And finally, the fragment shader. Again, we get rid of this stuff. This is an opaque shader, so we don't have anything to do with alpha, really, so we can get rid of the alpha stuff. We're not sampling a normal map or emission map or specular map, so we get rid of those guys. And here we make a call to universal fragment blin-phong, which does the lighting calculation. That we're going to need to modify probably, because it assumes that it has all this data like specular smoothness emission, which we don't have. So we're going to need to change this. So let's copy this. And a good way to work with this conversion process is to have both the built-in shaders, that is the built-in render pipeline shader library and shaders, and the universal render pipeline package in some text editor where you can kind of search through all the folders, because then you can find, what is the equivalent of transform some object space to world space in universal RP, so on and so forth. So I'm going to go ahead and search for this universal fragment blin-phong, which is in lighting HLSL, which we are including. And I'm just going to copy this and again get rid of the parts that I do not need. So paste this guy in. We don't need to mix real-time and baked GI. We don't need specular color. Additional lights we don't care about. A very simple use case with one directional light. We don't have emission. Specular is gone, and so on. And we don't really have an alpha, so I'm just going to pass 1. And then now that we've kind of pruned it down so much, we can get rid of the arguments that are passed into it. So spec gloss, smoothness, emission, alpha, all gone. So we just use diffuse, and we use input data. And actually, we don't have shadow coordinates, and there is an overload of get main light that takes no arguments whatsoever, so we can use that and save. Okay, just match it over here. Let's see where we're at. We're going to have several compiler errors step after step, but we're going to get through them. So, custom lit, we have some problems with Unity probe volume parameters. Where did we jump off to now? We are in the shadow library, okay? Go back to custom lit. Not that one. And take a look at what is going on. So we included lighting HLSL. We have our own custom CGink that we were using for our own shaders that included the main stuff like our custom lighting and the main structs that were being shared among all of them. We don't really need that anymore. Yeah, looks good. Let's do a re-import to get the errors again. Oh, we're already getting it. So tangent OS. It's saying I'm using it, but of course I got rid of it at some point. So this one I think I can just replace. Let's take a look. Output.normal. Our output struct is the varying struct, and the varying struct has the normal that we want to pass through. And let's just pass through it as it comes in for now. And get rid of this guy. And that normal input is not needed anymore. It says basemap st is not defined. Okay, you remember when I said previously we were using underscore main text, and now we're using underscore basemap, or universal RP is using that. You want to keep underscore main text, because if the properties match in between the two subshaders, then we're not going to have to reassign the texture in there. We can just keep it as it is. So here use main text, and any other usages, basemap, here we go, main text, and main text. And we actually need to declare main text. So if you look at simple lit, oh geez, how did I zoom in just now? Anyways, simple lit input. There is a declaration here of the texture and the sampler for the spec gloss map, but the one for the base map actually comes from surface input. And since we're not using it, we're just going to copy it, or using this include rather, and just change it to main text. So come here, change to main text, and to main text. Good, that should be the declaration of it. Done. We don't need the ST. Where was that again? Over here. We can just, because we're not doing any scaling or transforming of the, we're not doing any tiling with the texture outside of our world space UVing, we can get rid of this transform and just pass it right through. Okay, now it's complaining about normal because input does not have a normal but has a normal OS. Yeah. Okay. And we're using normal again here, we can get rid of that. Now sample albedo alpha. We don't have that in any one of our files that we included, so we go ahead and search through the Universal RP library for the definition of it, which is right here, and it's actually just calling another macro with this order of parameters, so we can use that instead. Just paste it here so I can copy stuff over. We're using UV and main text and sampler main text. There we go. Take this, replace sample albedo alpha, and base color. So simple lit had a base color defined. We don't use a separate color value. We can get rid of that one. And the normal TS being passed to initialize input data. I'm pretty sure we're not using that. Yeah, we can get rid of that. Whoops. Good, we're almost there. It says input data is not fully filled out. That is true, because input data struct is defined in here somewhere in the input HLSL file, and it's this big guy, and we don't fill it out completely, and the compiler complains about that. So we're going to copy it in and call it input data custom, and replace all kind of usages of it with that. There it is, whoops. There it is, looks good. And then get rid of the stuff in there that we have removed. View direction, shadow coordinates, fold coordinates, vertex lighting. That looks good. Okay, no more errors, seemingly. And if we switch between built-in and universal, now we see, okay, our texturing is broken again because we didn't re-implement the part where we do the world space UVing. That's pretty simple enough. Our original shader is down here. Here's the code for the UV switch. And we just put it in here and just make sure we have the right names for the structs. So instead of v.vertex, we have input.position object space, and here input.textchord xy. And we can get rid of this line. There we go. Okay, so now we have a slight lighting difference. Part of it is from the normals that this guy expects in the input data as world space normals. So I'm going to take a quick look at the completed shader to see what we did with the normals there. Normals, normals, normals. Wait a minute. Custom lighting comes from custom HLSL, and we transformed them from object space to world space. So go back to our custom lit shader and do this transformation. So, like so. Good. So now the only difference is a little bit of kind of lighting intensity difference you see in the lit shader. And I've spoken to the Universal Render Pipeline guides about it from Unity, and they say it might be with how we're in gamma color space right now, and how ambient colors that are not complete white or complete black, how they are handled in gamma space. So if we switch to linear space, this actually looks exactly the same. But this is something that can be fixed pretty soon, I'm pretty sure. Okay, good. So we did all this work. We got to a point where it looks almost the same as before, and actually a little lighting difference, but for what? So now when we click on our custom lit shader and switch to Universal RP, finally we see that we are SRP batcher compatible. So what does that mean? If we switch to the frame debugger and enable, we see some SRP batches in there. So not everything, because we didn't convert all our shaders to be SRP batcher compatible, but a lot of stuff is now batched by SRP, which is pretty good. If we took the time to do the rest of the shaders, that would also be the case. And of course, we would want to do it in a way that wasn't as hacky as what you just saw. We would want to take most of the stuff that we customized, put it in a custom HLSL file, and then use that in all the shaders that use the kind of same lighting model and the same structs and so on. So that's what it takes really to convert a shader the whole way to be SRP batcher compatible in Universal RP. It was probably a little bit fast for those of you who haven't looked at any shader code or Universal RP shader library before, but it's nothing you can't really get into, definitely. Second thing I want to talk about quickly is converting effects. So I have, for the built-in RP, one effect here on the camera, with the post-processing V2 stack. On the post-process layer, the layer is disabled, but on the volume, I have a grayscale effect. Very simple. If I turn it on, everything gets rendered grayscale, right? And there's even a blend parameter to go from full color to full grayscale. But if I switch to universal, it doesn't work, because universal RP is not compatible with post-processing stack V2. It has its own post-processing effects that come with it. So if you go here, we might be able to see them. Yep. So in the package, Universal RP shaders post-processing, you see a lot of the common post-processing effects that we know Unity has had, like bloom and Gaussian depth of field, Panini projection, and so on. They're all there, and you can use them. But we're going to do it in a bit more kind of lightweight way. And one way to do that is on the render pipeline asset renderer, we can add another renderer feature. So here I'm going to add the blit renderer feature. This one, so the one above that, the render objects one, that's both say experimental, that comes with Universal RP right now, but the blit one I actually took from a GitHub repository of Unity's. Let's take a look there, GitHub, LWRP custom render examples. It has LWRP in the name actually, but now you see it's called Universal Rendering Examples, and it's compatible with Universal RP 7 and up. And in this one, there was an additional implementation of this blit pass that I just took, and it actually makes it really easy to do custom blit effects on top of things. So it's right here. The blit pass is a scriptable render pass, has a bunch of parameters. You can create it, and then this execute gets called every frame once it's enabled, and it actually creates this blit pass. Actually, the blit, let's see here. Yeah, scriptable render feature creates the pass and kind of queues it every frame, as you can see over here, so that every frame, this happens after, actually whenever you want it to happen. So if you go back to where we assigned it, it's over here, we can say it should happen before rendering, after rendering opaque objects, after rendering skybox transparents, after post-processing, etc. Here we want to be done after rendering transparents. And then I'm going to go ahead and put my grayscale shader in there. And now you see the effect is also working in Universal RP. So if I switch between them, it's just the lighting difference from before that's affecting it, but both effects are working. And actually, this is the really nice thing about Universal RP is that many things that are kind of generalized effects or renderer features that you write can be just kind of plugged in here, and you can just set the parameters, and you can have multiple effects happening at different places of the rendering. It allows you to really hook into different parts of the rendering loop very easily. All right, going back to our slides. I don't know why we're in the intro one, but let's skip forward here. Okay, so we were here, we opened the demo scene, we looked at what it takes to upgrade shaders and what it takes to upgrade effects. There are some known issues, though, with Universal RP that might be a blocker for your project to be upgraded. And a couple of these are camera stacking and controlling UI rendering with Universal RP. I'm going to quickly switch back to the demo scene to show you what I mean. I have this overlay camera here. Let's make sure I'm in built-in RP. I am, and let's kill this grayscale. There we go. I have this overlay camera here, and most of us, I'm sure, used to having multiple cameras that can render on top of each other, and this camera is set to only clear the depth and then render this cube that's sitting over here, and the camera is right over here, on top of what the previous camera rendered. Simple, right? If we switch to built Universal RP, that doesn't work. If I turn off the camera, my scene works. If I turn it on, it overrides everything that was there. And the background type, it was a depth only before. Now there's don't care, solid color, and skybox, but none of them actually work. So this was something in the beginning they said they would not support camera stacking, but so many use cases have been reported by you guys and others that they decided to add it back in. And it is in research and in development at the moment. If we quickly go to the scriptable render pipeline GitHub repository, we can see there's a branch called camera stacking. And if you pull this branch, clone repository, you can actually put the package, this version of the package, into your project and use this camera stacking feature. It's just very early in development right now, and you might get some wrong results, but it is being worked on. And one thing I would actually advise you to do is to keep a close eye on the scriptable render pipeline GitHub repository for any new thing that might be in development. You could look at all the different branches there are 450 of them, but look at maybe just the active branches. There are a lot of different releases. You can get to know about them. You can look at each of the packages. You can look at pull requests that people have created. And you could even go to Insights and go to the Network tab to see who has forked this repository and done what with it. This takes a while to load, so I won't wait for it because it's a huge repository. That's one known issue. That's another known issue. OK. UI rendering. So as of right now, UI rendering is not exposed to the scriptable render pipeline at all, as far as I have could see and also try to confirm with people from Unity. If we take a quick look at Universal RP runtime and the actual Universal Render Pipeline C# script, you can see a lot of stuff in here. Let's see. Go down, go down, go down. Camera data. Keep going. I want to show you specifically the passes, the different passes that are being done. Maybe I don't see it here, but forward render. OK, here we go. There are all these passes that may or may not be run per frame, depending on the features that you've enabled. So there is the draw objects pass, draw skybox pass, draw transparent objects, post-process, etc. There is nothing regarding UI, unfortunately. So UI rendering is still completely kind of in the engine and not so much exposed to SRP. And they said this is something on their radar, and they would like to work on it sometime in the next year, kind of expose it, but it's just not there yet. So something to keep in mind. There is a workaround for it, which is that you can use a camera to render all your UI to an off-screen kind of render texture, and then composite that on top of your normal image, and then you can kind of do what you want. But it's not as easy as it used to be at the moment. OK, quickly switching back to presentation to wrap things up. OK, there are a bunch of resources that I want to mention that we already actually saw a few of them. So if you have upgraded your project to LWRP but want to go to Universal RP, there's an upgrade guide that Unity has published. There's a blog post about it. The documentation, of course. There's a feature comparison table that shows you the differences between built-in render pipeline, universal pipeline, what is supported, what is not supported, what is in research. There is this custom renderers example repository that you saw, the scriptable render pipeline GitHub repository that's really good to keep an eye on. There's a blog post about the SRP batcher and what it takes to be SRP batcher compatible. Really good information in here. Actually, it's stuff that's really not in the documentation, but like here. And there is a custom render pipeline tutorial from Catalog Coding that I liked a lot. So if you want to completely write a custom render pipeline, you could follow this series and learn a lot. Here's the project URL, as I promised you. If you go here, you will find this project that I used just now to show you all this stuff, along with the completely converted shaders for you to learn from. Thanks a lot.